Unlike the rocky constituents of inner planets, the four giant outer planets are made up mostly of gas. These heavy objects have dozens of moons around them, each creating a miniature planetary system. All four outer planets are much larger than Earth. But despite their size, they have shorter days and nights than the Earth. This rapid rotation causes the atmospheric layers to split into several different sections. The spacecraft that have visited these objects have shown that all of these planets have magnetic fields and that an aurora borealis occurs in their atmosphere. All four outer planets have rings around them, but Saturn's rings are more magnificent and wider than the others. Jupiter. Jupiter has a diameter of 142,984 kilometers and can accommodate more than 10 planets the size of Earth. The massive mass of the largest planet in the solar system affects the orbits of many objects in the system. Over billions of years, it has deflected the orbits of countless comets. This vast planet also has a strong magnetic field that traps very energetic particles around it, making Jupiter dangerous for human exploration. The large red spot on Jupiter's surface is due to a massive and unique hurricane in Jupiter's atmosphere that has been going on for at least 300 years. The width of this storm is usually 30,000 kilometers, and 2 to 3 objects the size of the Earth can easily fit in it. Its shape is constantly changing, and its red color is probably due to chemicals being drawn from the depths of Jupiter's atmosphere. Jupiter's fourth largest moon is an icy world. The cracked surface of Europa covers an entire ocean of liquid water, the tidal effects of which provide the heat needed to keep the water liquid. The combination of water and heat means that the Europa is one of the few places in the solar system prone to life. Saturn. Saturn, with a width of 120,536 kilometers, is the second largest planet in the solar system. The planet also has an atmosphere similar to Jupiter. But the structure of its clouds shows less activity. The planet is surrounded by a magnificent set of rings that are probably remnants of a shattered moon. Saturn's largest moon, Titan, has a dense atmosphere with air pressure higher than Earth's at sea level. Saturn's rings are made up of almost pure ice cubes and small amounts of dust. One of the largest rings, the E ring, is still fed by erupted ice particles from Enceladus. The rings are divided into several regions of different densities, and the gravitational effects of Saturn's moons keep them in orbit. One of Saturn's moons, called Enceladus, which is 504 kilometers wide, is the most reflective object in the solar system. Its clear icy surface covers an ocean of liquid water that is likely to be one of the farthest shelters of life in the solar system. Ice volcanoes near the Enceladus's south pole release ice grains and water vapor into space. Uranus. Uranus is the first planet to be discovered using a telescope and is, in fact, a strange world. The planet is 51,118 kilometers wide and rotates sideways, with long seasons and severe climatic consequences. In the middle of winter, there is no phenomenon in its atmosphere. Still, with the arrival of summer and the warming of the equator, intense activities begin in it. The planet's thin rings were first discovered in 1977 when they stopped the light of a star for a short time. The methane in Uranus' atmosphere absorbs red light, which is why Uranus is blue. The planet has a large solid core. The nucleus is probably composed of an icy body that grew large enough in the planet's early days to absorb the surrounding gases. Neptune. The existence of this planet and its approximate position were predicted using its gravitational effects on other planets. Neptune is 49,775 kilometers wide, and its atmosphere is much more active than Uranus. So, it has huge storms. The planet has a large moon called Triton, whose reverse orbit indicates that it was an asteroid that Neptune's gravity had captured in the distant past. Neptune's rings are uneven and consist of concentric arcs of material trapped inside thin rings. In 1982, during the last leg of its voyage to the far reaches of the Solar System, the Voyager 2 spacecraft photographed material in Joe Neptune that we now know as the white clouds in Joe Neptune are actually frozen methane. Like other giant planets, Neptune's atmosphere mostly consists of hydrogen and helium. Like Uranus, Neptune has methane. Neptune's atmospheric activity and high-speed winds indicate an intraplanetary heat source.